our isothermal expansion case. And in a perfectly reversible sort of imaginary system, all the heat that flows in goes to doing work as opposed to doing any temperature change, right? The energy change in this system for the ideal gas case was 0, right? We had no change in temperature. All the heat that flows in from the heat bath after we let go of this compressed piston and let it expand, all the heat is perfectly turned into work to move the piston up in our, if it were possible to be sort of our reversible case. So there was no change in energy in this system, okay? But we knew that the expansion would happen spontaneously. So energy,
So, I'm not entirely.
Okay.
So if something would result in higher entropy, is that just like guaranteed to what's the spontaneity?
So that's a great question. And a good example that we can do that we haven't gotten to yet and we'll talk about extensively after spring break is this situation here. So let's say these are, what does this look like? And say this goes all the way around. What is this, the cartoon version of? The lipid bilayer. Did I draw backwards?
Yeah.
Here we go. This makes more sense. All the polar groups want to be on the outside. All the non-polar tails want to be on the inside. Right. This would be the cell membrane. It's a lipid bilayer. It's no longer inverted, too. What's the entropy of the system here? What's the entropy of this system here? It's really organized. Is this spontaneous? Yeah, it is. It happens all the time in your body. The assembly of lipids or micelles or cell membranes, they self-assemble into this. So even though entropy went way down, obviously something let it be spontaneous. Right? So this is where Gibbs free energy comes in. Gibbs free energy is equal to change in enthalpy minus T delta S. Okay. This can go down, and this can still be less than 0, such that it happens spontaneously. I need this information. Okay. Like I said, we'll talk about this more, but basically what happens from here to here is a whole bunch of hydrophobic interactions are happening. These are very, very favorable. This is a nice big negative number, okay? Such that it doesn't matter that I'm subtracting a decrease, right? But forthcoming. But yeah, so entropy, it can go up or down. What's happening with spontaneity depends. I have to know Gibbs free energy to say definitively what's going on. But things want to maximize entropy if they can. And the only way they won't and still happen spontaneously, you must be making a whole lot of really favorable enthalpic interactions. Okay. It's a good question. So we kind of have an idea of what's happening to things spontaneously. Again, it's important to note that a change in free energy being negative is the only way to say absolutely without question that something is spontaneous. So we had previously only really looked at delta H. Okay. Now we're starting to talk about what's going on here, and we'll put it all together the week after next.